We can use a math machine to evaluate an expression. The following math machine shows how to evaluate the expression 4b subtract 1 for any input b. It says, to evaluate the expression 4b subtract 1, you must take the input b, multiply it by 4, and then subtract 1 from the result. The output is the value of the expression 4b subtract 1. Remember, it is the order of operations that tells us that we must multiply before we subtract. What is interesting is that we can work with a math machine in two different ways. First, if we are given the input, then we can determine the output. For example, consider the math machine which represents the expression 4b subtract 1. If b equals 3, then input 3 into the math machine and follow the steps to determine the output. So 3 times 4 is equal to 12, and 12 subtract 1 is equal to 11. Therefore, if the input was 3, then 11 will be the output. We can show this same process using algebra. Inputting 3 into the math machine is the same as substituting b equals 3 into the expression 4b subtract 1, and then evaluating. We would show this as 4b subtract 1 equals 4 times 3 subtract 1 equals 12 subtract 1 equals 11. It is very helpful to recognize that inputting a number into a math machine to determine the output is similar to substituting a value into an expression and then evaluating. The second way that we can work with a math machine is to use a given output to determine an input. Again, let's consider the math machine for 4b subtract 1. If the output is 27, then we can take the output and reverse the actions of the machine to find the input. In the original machine, the last step we took was to subtract 1, and so this is the first thing that we must reverse. Since addition is the opposite of subtraction, we reverse subtraction of 1 by adding 1. So we take 27 and we add 1, and we get 28. Now, we must reverse the multiplication by 4. Since division is the opposite of multiplication, we take 28 and divide it by 4, and the result is 7. To check our answer, we can run 7 through the machine. If we're right, then 27 should be the output. So 4 times 7 is equal to 28, and 28 subtract 1 is equal to 27. Therefore, if 27 was the output, then 7 must have been the input. We can also determine the value of b using algebra, and we can use the math machine to help us. We are given the output of the machine, which is 27. This is the same as being told that the expression 4b subtract 1 is equal to 27. To find the value of b, we can now solve this equation. We start by looking at the left side of the equation. There are two parts to this expression, 4b, which represents 4 times b, and then the subtraction of 1. Moving backwards through the math machine suggests that we deal with the subtraction of 1 first. Remember, to do this using algebra, we must add 1 to both sides of the equation. We would show this as 4b subtract 1 plus 1 equals 27 plus 1, which simplifies to 4b equals 28. To solve for b, now we just have to divide both sides of the equation by 4. We get that 4b divided by 4 equals 28 divided by 4, which simplifies to b equals 7. Again, it can be very helpful to recognize that reversing a math machine to determine the input is similar to solving an equation. Let's now take a moment to compare the forwards and backwards movement through the math machine. The following math machine shows how to evaluate the expression y divided by 3 plus 7 for any input y. If we are told that the input is 12, then we would work forwards through the math machine. We saw that moving forwards through the math machine is the same process as evaluating the expression y divided by 3 plus 7 when y equals 12. Alternatively, if we are told that the output is 11, then we would work backwards through the math machine to determine the input. Moving backwards through the math machine is like solving the equation y divided by 3 plus 7 is equal to 11. The differences between working forwards versus working backwards through a math machine are similar to the differences between evaluating an expression and solving an equation.